Section 4.7 is a general strategy session here on factoring. And there's basically one objective, and that's to factor polynomials completely using any of the methods considered in this chapter. And as an example, we are looking at a polynomial here, 3y to the third minus 12x squared y. And you may remember one of the first things you want to do to see, if there's a common factor among the coefficients and the variables, and sure enough, the 3 is a common factor. So we can factor out a 3, and y is also common to both terms, so we can factor out a 3y. And then we have a y to the second minus 4x squared, and we recognize that as a difference of two squares. Y to the second, that's pretty obvious. And when we write 4x squared as 2x in parentheses squared, then we can factor this as 3y times y plus 2x times y minus 2x. So we've factored this expression completely. Each factor is a prime polynomial. In other words, it's a polynomial that cannot be factored anymore. And then we can check the answer. And again, I leave that up as a practice exercise for you. You should probably do it in probably every case, just to develop that ability to do that. And so let's move on to the next example.
No.
So therefore, the answer is 7 times a minus 1 times a squared plus a plus 1. There would be the complete factorization of the given expression. So number 5, we realize that the greatest common factor for each of the coefficients is 3, so we can factor out a 3, and so we have 2x squared minus x minus 6. So here we have a trinomial, and if we use the AC method, on that was a equals 2, b equals minus 1, and c equals minus 6. Then we have a times c. 2 times minus 6 is minus 12. And we want to factor minus 12 into p and q integers, so that p plus q equals negative 1. Well, minus 12 could be factored in, 2 times negative 6, or 3 times negative 4, and I think that might work because 3 times minus 4 is minus 12, and 3 minus 4 is minus 1. So there would be the integers p and q to rewrite the middle term. So this becomes then 3 times 2x squared plus 3x minus 4x, so with the other coefficient, minus 4x minus 6. And that then becomes, maybe factor by grouping now, 3 times, this is our first group, and we can factor out an x. So x would be the greatest common factor, so x times 2x plus 3, which would be the binomial for the second group, 2x plus 3. So in this case, we have to factor out a negative 2, because minus 2 times 2x is minus 4x, and minus 2 times plus 3 is minus 6. So now we have as greatest common factors 2x plus 3. So 2x plus 3. And for the other set of parentheses, we have x minus 2. So x minus 2 times the 3 we had factored out originally. So that would be the complete factorization of this expression here. So I wrote the complete answer here as 3 times x minus 2 times 2x plus 3. So for the next exercise, number 6, we see that 5 is the greatest common factor for the coefficients. So we have 5 times y to the 4th plus 4x to the 6th. Now we realize that this could be written as y squared to the 2nd power, and this could be written as 2x to the 3rd. So it'd be 5 times, put brackets in here, y squared to the 2nd power plus 2x to the 3rd raised to the 2nd power. But this is now the sum of two squares, and we know, or at least we hope we remember, that the sum of two squares is always prime. So that's the only factorization that's possible here, by factoring out the greatest common factor. In number 7, we look at this as maybe like factoring by grouping almost, but we look at the first group. And the greatest common factor here is a, so we can factor out an a. We get a squared minus b squared. And in the second group, we can factor out a minus b, so minus b times a squared minus b squared. And now we can see that a squared minus b squared is the greatest common factor in this expression, so we can write this as a squared minus b squared times a minus b. So that's the factorization. But now, if you look at this expression here, you see that we have an a squared minus b squared, the difference of two squares. So that would be a minus b. That's this one here. And we're going to write a squared minus b squared as a plus b times a minus b. So all these expressions are equivalent. And now we realize that we have two a minus b's here. So we have a minus b to the 2nd power times a plus b. So that's the final answer. Let me write this up here. So it's a minus b squared times a plus b. Again, so when you look at an expression, first question is the greatest common factor? What else am I looking at? What are the possibilities? The AC method, like in the example number 5, or here in this case, we realized we got stuck with the sum of two squares. In other words, we could only factor out the greatest common factor. So all of it's really a matter of experience, and obviously, the more exercises you do, the more experience you will get. This is the end of section 4.7. Section 4.8. It's about applications of polynomial equations and functions. And so the objectives are to solve quadratic and other polynomial equations first by factoring, and then using the principle of zero products. That's a very important principle, as you will see. And then we solve some applied problems involving quadratic and other polynomial equations that can be solved by factoring. So a new principle that we are learning here is this, the principle of zero products. For any two real numbers a and b, if a times b is 0, then a is 0 or b is 0 or both. If A is 0 or B is 0, then A times B is 0. So in other words, it goes in both directions. If the product is 0, then either one or both factors are 0. If either one or both factors are 0, then the product is 0. So again, that may not be too surprising, but you'll see how we're going to apply this here in just a little bit. So let's look at example number 1. Solve x squared plus 8 equals 6x. This is a quadratic equation because the variable is squared. And so in many cases it indicates that there are two possible solutions. And so like in linear equations where the variable is only raised to the first power, we want to isolate the variable x, and that's also true here in this particular case. But look how we go about doing that. First of all, we subtract 6x on both sides, so we're going to rewrite this expression as x squared minus 6x plus 8 equals 0. Now if we look at the left side, that's a trinomial, and we can factor that into x minus 2 times x minus 4 equals 0. In words, x times x is x squared, x times minus 4 is minus 4x, and minus 2 times x is minus 2x. So combined we get a minus 6x, and minus 2 times minus 4 is positive 8. So we're okay with that. So now what that means, when we look at the zero product property, what it means is, sorry about that. So we rewrote this as x squared minus 6x plus 8 equals 0. We factored the left side, and now we have the product of two numbers that equals 0. And so now that tells us that x minus 2 equals 0, or that x minus 4 is equal to 0. Okay. So now, of course, that is a very simple equation to solve. We add 2 to both sides, so that x equals 2. In this case, we add 4 to both sides, so x equals 4. So what's happening here is that a somewhat complicated expression, something raised to the second power, has been reduced to two expressions to the first power. X minus 2 is x to the first power, except we now have two equations, but they're relatively easy to solve. X minus 2 equals 0, that's a pretty easy equation to solve. So these then are our two solutions. So both numbers check. So the solutions are 2 and 4. So that's how we can solve quadratic equations, by factoring them and then setting each factor equal to 0. So x minus 2 is a factor and x minus 4 is a factor. Remember, these are expressions in parentheses with a multiplication sign in between. So in other words, factor 1, factor 2, we set each factor equal to 0, solve each one for x, and then there's our solutions. The solutions are 2 and 4. So here's a general strategy for solving an equation using the principle of zero products. Obtain a 0 on one side of the equation, typically that's on the right side. Then factor the other side, set each factor equal to 0, and solve each of the resulting equations for the variable. So it's a four-step process. And you just saw a moment ago how that works. Here's another one. So 5y plus 2y squared equals 3. So obtaining 0 on one side, in this particular case, we simply subtract 3 on both sides. And let's start with the leading coefficient as 2y squared plus 5y minus 3 equals 0. Okay? So now we have a little trinomial here on the left side, and we can factor that using the AC method. Let's just do that. So in this case, a is equal to 2, the coefficient of the variable squared, and b would be equal to 5, and c is equal to negative 3. So when we form the product of 8 times c, that means 2 times minus 3 is minus 6, and we want a factor of minus 6 in such a way that the sum of the factors is equal to 5. So since the product is negative, one of the factors, p and q, has to be positive, and the other one has to be negative. So we could, for example, have minus 2 times 3. It would be minus 6. But the sum, p plus q, would be equal to 1. So that doesn't work. We could also say minus 1 times 6. Minus 1 times 6 is minus 6. In this case, minus 1 plus 6, of course, is equal to 5. And that's what we wanted, right? So what it means, we use minus 1 and 6 as coefficients to rewrite the middle term, to split the middle term. And we have done this many times before, so this becomes 2y squared minus 1y. I'll be very explicit here, plus 6y minus 3, all equal to 0. So now in the first group, we can factor out a y. So we get y times 2y minus 1. That would be our binomial for the second group, 2y minus 1. So we need to factor out a 3 in this case, a positive 3, because 3 times 2y is 6y, and 3 times minus 1 is minus 3. And so our greatest common factor is 2y minus 1, 2y minus 1. And for the other parentheses, we have the y here, and we have a 3, y plus 3. So that's a factorization of the trinomial 2y squared plus 5y minus 3 equals 0. That's a factorization. And according to the way we solve this equation now, we set each of the factors equal to 0 and solve for the variable. So this is the first factor, y plus 3. We set that equal to 0. And we set the second factor equal to 0 also. So 2y minus 1 equals 0. And we solve this equation by subtracting 3 on both sides. So y equals negative 3. And this then, here we add 1 to both sides. So 2y equals 1. We divide by 2 on both sides. So y equals 1/2. So the two solutions are then y equals minus 3 and y equals 1/2. So then the answer would be minus 3 and 1/2. So it would be the solution set. For the next exercise, 8b squared equals 16b. Let's rewrite this as 8b squared minus 16b and factor out the greatest common factor, which would be 8b. So 8b becomes then a b minus 2, and that's equal to 0. So we have two factors that we set equal to 0, 8b equals 0, and b minus 2 equals 0. So that means we divide both sides by 8. That means that b equals 0. That's one solution. And the other solution, b minus 2 equals 0. So we add 2 to both sides, so b equals 2. So these then are the two solutions, b equals 0 and b equals 2. So what this really means is that 10x to the third plus 13x equals 3. And by subtracting 3 on both sides, we get the expression 10x squared plus 13x minus 3 equals 0. So this is a trinomial that we want to factor. So use any method you want, but let's say we use the AC method, then this trinomial becomes, when we factor it, becomes 2x plus 3 times 3x minus 1 equals 0. Now we set each of the factors equal to 0 and solve for the variables. So factor number 1 is 2x plus 3 equals 0. And the other factor is 3x minus 1 equals 0. So you subtract 3 on both sides. So 2x equals negative 3, divide by 2. So x equals minus 3 halves. 3 divided by 2. And this one now we add 1 to both sides. So 3x equals 1, or x equals 1/3. So those are the two solutions. Actually, the factorization was 2x plus 3 times 5x minus 1. And so then 2x plus 3 equals 0, x equals minus 3 halves, as before. But now we have 5x minus 1, or 5x equals 1. We divide by 5 on both sides, so then x equals 1/5. So the two values for x would be minus 3 halves, or minus 3 divided by 2, and 1/5. Here's another interesting question. Find the domain of the function g if g of x equals 2x minus 9 divided by x squared minus 3x minus 28. So what are we going to do with that? So find the domain of the function g if g of x equals 2x minus 9 divided by x squared minus 3x minus 28. And so remember, this function exists for all real values of x for which the denominator is not equal to 0. We don't worry about the numerator being equal to 0, because if the numerator is equal to 0, then the function value is 0. But we have to be careful with using numbers that would cause the denominator to be 0. So what we do in a case like this, we take the denominator, x squared, minus 3x minus 28, and set it equal to 0 to determine the values of x for which this expression would be 0. Using the AC method or any other method that you prefer, this becomes an x plus 4 times x minus 7 equals 0. So now we set each factor equal to 0. So when we set x plus 4 equal to 0, then x is equal to negative 4. And when we set the second factor equal to 0, x minus 7 equal to 0, then x equals 7. And what this means is that this function is defined for all x, such that x is a real number, with x not equal to minus 4, or x is not equal to 7. Actually, there should be an and here. So in other words, as long as x does not take on the value of minus 4 or the value of 7, this function is defined. So I hope that thought pattern made sense, that this function is defined for all values for which the denominator is non-zero. So again, what we do is to find out for which value it is equal to 0, we set the denominator equal to 0, we solve for x, we find two values that would cause the denominator to be 0. So those are the values that have to be excluded from the domain. So the domain equals the set of all x, such that x is a real number and x is not equal to -4 and x is not equal to 7. So here's an application, and it's about a fireworks display. Fireworks are typically launched from a mortar with an upward velocity, the initial speed of about 64 feet per second, the height t, h of t, in feet of a so-called weeping willow display, that's the fireworks, t seconds after having been launched from an 80-foot high rooftop is given by this expression, h of t equals -16t squared plus 64t plus 80. Now the question is, how long would it take the cardboard shell from the fireworks to reach the ground? So let's make a little graphic representation what this all means. And this is going to be a little bit rough here, but let me just draw it out for you. So here is time in seconds, t in seconds. And here's the height of the projectile measured in feet. And here's 0. What this expression tells us that when t equals 0, then this term is 0 and that term is 0. So it starts at 80 feet, as I said here, 80 feet from an 80-foot high rooftop. And then it rises as a function of t, so time goes in this direction, time. It goes up, it has the highest point, and then it eventually reaches the ground. So the question is, how long will it take the cardboard shell from the fireworks to reach the ground? So in other words, what is this value for t here? That's the question. Okay? So when it reaches the ground, the height obviously is equal to 0. So we have to set this whole expression equal to 0. So you have -16t squared plus 64t plus 80 equals 0. So the greatest common factor is obviously 16. So we factor out a -16. So we get a positive leading coefficient of 1, t squared, minus 4t minus 5 equals 0. We can factor this trinomial, 16t squared minus 4t minus 5, as t minus 1 times t plus 1 times t minus 5 equal 0. So we have three factors here. Now, first of all, -16 cannot equal 0, so we just need to look at these two factors here. So we set t plus 1 equal to 0, t plus 1 equals 0, or t equals -1, second. And when we set the second factor equal to 0, t minus 5, then t minus 5 equals 0 means that t equals 5 seconds. So we have two solutions here. And now we have to look at this and say which of these two solutions make sense. Sometimes both solutions make sense, and sometimes only one makes sense. And in this example, in this case here, the t minus 1 does not make any sense because time is not negative. Time has a positive value. And so the only other possibility is that t equals 5 seconds. That means after 5 seconds, the cardboard shell from the fireworks will reach the ground. So t equals 5 in this example. And that's fairly typical when you have applied problems, that you have two solutions, and you have to be very careful to evaluate which one makes sense in the context of the problem. Sometimes, again, as I mentioned, sometimes both solutions make sense. In many cases, only one solution makes sense. So you have to evaluate that on a case-by-case basis. I rewrote the answer here underneath the problem after 5 seconds. The next concept is one that you've probably seen before, the Pythagorean theorem. Most people have heard about it, some even understand it. But it's like this. You have a right triangle here with a hypotenuse C, and then the two legs A and B with a right angle between the two legs. And so what this says is that the sum of the square of the length of the legs of the right triangle is equal to the square of the length of the hypotenuse. It's called the hypotenuse. So the very famous formula, a squared plus b squared equals c squared. Very basic one, and now we're going to learn how to apply that. Here's the problem statement. Triangle dimensions. One leg of a right triangle has length 10 centimeters. The other sides have lengths that are consecutive even integers. Find these lengths. So let's think about what this even means. So what does two consecutive even integers mean? Let me just explain this a little bit. Let's say we have an even integer like 12, and the next one would be 14. So note that we can write this as 12 and 12 plus 2. In general, if x is an even integer, then the next even integer would be x plus 2. So here is the beginning. Familiarize yourself with the problem. Let x and x plus 2 represent the lengths of the unknown sides of the triangle. So let's draw a right triangle. And so here it is. And we are told that one leg has length 10 centimeters. So that means for the other two sides, it's x and x plus 2. And so the x plus 2 is the hypotenuse because it's going to be longer than the other one here. And now applying the Pythagorean theorem, a squared plus b squared equals c squared, that means x squared plus 10 squared equals x plus 2, parentheses squared. So a squared plus b squared, x squared plus 10 squared equals c squared, and c is equal to x plus 2. So that would be x plus 2 squared. And in other words, this then becomes x squared plus 10 squared, or 100. And we know what x plus 2 squared means. X squared plus 2ab, 2 times 2 times x, or 4x, plus 2 squared, or 4. Now we combine like terms on both sides of the equation, and then we wind up that the x squares cancel, and then we have 4x plus 4 and the 100. We combine this further, and then 4x equals 96 by subtracting 4 on both sides. So then x equals 24 centimeters. So if x equals 24, then x plus 2 is 26. 2 more than 24. And now we check. Is 10 squared plus 24 squared equal to 100 plus 576? Is that equal to 26 squared? And so 676 is equal to 26 squared. So last we state our answer. The lengths are 24 centimeters and 26 centimeters. This concludes section 4.8.